Determine whether this type 1 improper integral converges or diverges. If it converges, let's find the value. And what's our integral here? Negative infinity to negative 3 of 1 over x. Now, if we were to imagine the graph here, negative 3 here, negative infinity heading off that way. So I would expect negative area if there is. And definitely, as we head towards negative infinity, our curve is getting closer to 0. So it might settle down enough for there to be a finite area. But let's actually walk through the integration, the limit calculation, and see whether or not there is an area. Okay, does this converge or diverge? That's the first thing we have to answer, and then we'll worry about what the value is, if there is one. Okay, so we pick a sort of stand-in real number that we will make bigger and bigger on the negative side. And the reason we have to do this is because we can't integrate with infinities lying around. But if t is just some real number, well, we definitely can do that. Fundamental theorem of calculus comes and helps us. Okay, so now we have to think, do I know an antiderivative for 1 over x? And if your gut reaction is to say, yeah, ln x, you may need to stop and consider what we're talking about. We're talking about negative values, and ln doesn't like things. So in a second, when we try and plug in negative 3, we're going to have a bad time. Ln of negative 3 simply isn't there. And this is a situation where we have to use the better answer to what is an antiderivative for 1 over x, ln absolute value of x. So t in negative 3. Okay, and then we'll have ln absolute value of negative 3, which will just be ln of 3, minus ln absolute value of t, which would technically be ln of negative t, because t is a very, very big negative number. Okay, so I suppose we can bring the 3 out, and we can really just focus on ln absolute value of t. Now, as t is getting bigger and bigger on the negative end, absolute value of t must be getting bigger and bigger as a positive number. And if we think about ln, either we know properties of ln or we have a graph handy, okay, then we might remember that ln heads towards negative infinity as it gets closer to the positive side of 0, but other than that, it just keeps getting bigger and bigger, in the same way that e to the x keeps getting bigger and bigger, because these guys are mirror images of each other. Okay, so e to the t and then ln of t, I guess. Well, x. We'll change it to x. Okay. So what does that tell us? Well, ln absolute value of t is going to head off to infinity. So sadly, no. This limit doesn't exist. The whole thing diverges. So even though it looks like there might be finite area, it doesn't shrink. 1 over x doesn't get close enough to 0 fast enough. So there we go. Our type 1 improper integral diverged. But we have the limits and the calculations to show it.